Okay, next we're going to speak about the ASA firewall NAT. So to begin, we're going to speak about what NAT is, what are the NAT options, what is the implementation on the ASA firewall, and then in the next section we're going to look at the actual configuration of a couple of NAT types. But of course, for the CCNA exam, we're just going to do some basic configurations back and forth, because otherwise NAT by itself, it is a very big technology, a lot of options, features, and a lot of things that you should ideally be aware of. So to begin with, let's start with the basics. So what is actually NAT? Again, let's think about the acronym. So NAT stands for Network Address Translation, which pretty much is self-explanatory. Basically, we would want to translate network addresses, which means, because the network is the TCP/IP layer 3, it means we want to translate the address from the layer 3 header, which is going to be nothing else but the IP address source and destination. So given that a system performing NAT, which can be of course a router, a switch, a firewall, whatever layer 2 device has NAT capabilities, that system may change depending on the NAT configuration or translate the following fields from an IP flow. So based on your NAT configuration, that NAT device may choose to change or translate out of the source IP address, the destination IP address, the source TCP/UDP port, or destination TCP/UDP port. So either of them or all of them at the same time. Now it is called network address translation, even though we can also translate layer 4 information, probably because initially NAT was designed, let's say, to translate layer 3 only, and at the same time it doesn't make sense to translate layer 4 information without translating also layer 3 information. So NAT device again may choose to translate or change any of those 4 informations, or all of them, or any combination of them, of course based on your configuration and the capabilities which are supported by the NAT device. So now a bit of history, which it is going to make sense based on what we're about to speak next. So although today we use NAT in different designs with various scopes, we use NAT to provide communication between overlapping subnets. Like for example, imagine you have like 2 companies, company B, they want to speak with each other, IP traffic back and forth, and of course, but it can happen that both companies internally use the same IP addressing, the same private IP addressing. Like each of the companies has, let's say, 10.10.10.0.10.10.0.4, and each company wants to provide communication with the other company, but because it's the same subnet, in order to make that connectivity happen, we are gonna need to configure a NAT both ways in that specific design. So nowadays we use NAT for a lot of purposes, but to better understand the NAT configuration, the NAT terms, we have to understand what is the initial scope of NAT, which is nothing else initially but to provide connectivity between LAN resources and the internet. That was because per the RFC 1918, in the LAN, on the inside network, on the protected network, usually you have private IP addressing, and the problem is that private IP addresses are not routable on the internet. Like for example, if you look at our diagram, assuming that this is our network border in here, where in this direction it is the internet. So in that direction we have the internet. RFC 1918 addresses, which are private IP addresses, are not routable on the internet. For example, this would be one of the subnets, which means I'm gonna send traffic from that subnet, from that VLAN outside on the internet. At some point in my network, on any of the layer 2 devices which support NAT capabilities, I have to translate the subnet to something which is routable on the internet, because the source IP address is not routable in the internet, and most providers also drop all traffic being received inbound from the client, from the customers, if it has private IP addresses. So like if this would be the ISP router, technically speaking, the ISP should have an inbound filter in here which should drop all IP traffic if it's received with private IP addresses. So that was the initial scope of NAT from back in the days. Now, when Cisco added NAT capabilities first to their iOS code, which was the code on routers, because Cisco started with routers to begin with, then they added a lot of other, let's say, they added a lot of other network devices. They added switches to their platforms, to their business, by buying the CatOS company. They added firewalls and so on, access points, wireless capabilities, etc. But initially they started with routers. So at the point when they have added NAT capabilities on the routers, which the routers were running the iOS code, at that point, the inside was considered to be the LAN side, so the protected network where the private IP addresses were being with the private IP addressing scheme, and the outside was considered to be the WAN or the internet, where you would go out on the internet to reach whatever resources are not in your network. So we have to understand that was the initial scope, because as we're going to see in a couple, based on that initial design of NAT, inside being the LAN side and outside being the WAN or the internet side, they have defined the following in the NAT terms. We have something which is called inside local and inside global, outside local and outside global. And it's a lot of confusion into what those terms mean and how do we remember those terms. Because again, we have to understand how NAT was, designed by Cisco. What was their mindset and what was the scope of NAT in order to understand those terms. And because memorizing those terms again is not going to help, you have to understand exactly what each term means, and it is going to make sense in a couple based on what we already talked about, the history of NAT, and based on what I'm about to show you next in a couple. So before we go to a diagram and speak about all of those terms, the baseline is that the inside local address, so those terms are going to represent inside local, inside global, outside local, outside global, represent an IP address. So the inside local is going to be the real IP address of a host from the inside, so from the LAN side, is visible on the inside or local. The inside global is going to be the translated IP address or the mapped IP address of a host from the inside. So it's still an inside type, an inside term, but is visible on the outside, where the outside is global. So I'm going to, of course, explain in a couple on the diagram. It's going to make much more sense. But again, remember that the LAN should have been your inside NAT interface. That's how they designed it to begin with. And the internet, the outside or the global, because facing the internet, you're facing the global network, which is the internet. So that's how you should look at the local term, local meaning the LAN side, and the global term meaning the internet, everything else which doesn't belong to your company. Likewise, you have outside global, which is the real IP address of host from the outside, as visible on the outside or global. And the outside local is going to be the mapped IP address of a host from the outside, because it's still an outside type of address, but is visible on the inside or on the local. To better understand this, there's a Cisco document which I'm going to make use of to explain this functionality, and it's going to make a lot of sense. For example, let's assume that this is going to be our NAT device. Doesn't matter if it's a router, switch, firewall, that's going to be our NAT device. And as you can see, they put in here that they said in here that on the left side we have the inside network, which is going to be hosts with IP addresses from the RFC 1918 private addresses, and this is going to be the outside network, which means the internet. And for the sake of it, so based on the initial Cisco design, it means that when you would enable NAT on the iOS, because in this direction you're facing the inside network, which means the protected network, which means the private IP addressing scheme. Configuration wise, you're going to go on that device, which was the router, and make this interface in here as IP NAT inside, because it's facing the inside network. Inside. Likewise, because in that direction you're facing the internet, the outside network, or the global network, which means the internet. You're going to configure this interface as your outside NAT interface. So the interface facing the LAN, the inside is going to be the inside NAT interface. The interface facing the WAN, the internet, or the global network is going to be the outside NAT interface. So now, following this use case, let me actually zoom in a bit more. So given that this is going to be our inside NAT interface, inside, and this is going to be our outside NAT interface, let's assume that you have a packet flowing this way. So this host wants to get access to the internet. And let's make that traffic flow so in that direction. Let's assume that this host in here, this host, has an address of a private address of, let's say, 10.10.10. 10.10.10.10. And this host in here, being the outside host on the internet, has, let's say, a public address. So it's going to be an address of, let's say, 2.2.2.2. And looking at that traffic flow, we want the inside host to be able to get access to the outside host, so IP communication. But because the inside host has a private address, we have to translate or NAT that address as traffic goes out on the internet. So what this means is that as the inside host is going to initiate the traffic is going to be initiated with a source of 10.10.10.10, destination of 2.2.2.2. So that's what our router which performs, and that is going to receive as an IP packet. Now this address, this is going to be the inside local address. Now inside, because it's an IP facing the inside NAT enabled interface. And local, because it's facing the inside NAT interface, which means it should be the real address. The local stands from local LAN, basically the local area network, which means the private IP addressing scheme. So inside local means is the address facing the inside interface. And because that's the inside interface, it means it faces the local area network. There we go. That's why the term is inside local. Now, when the router receives that traffic, the router has to translate the source address before routing the packet out on the internet, because otherwise that source address is not routable. So when the router sends that traffic further on to the destination, it has to translate the source address to something which is routable. Let's say it's going to translate the source address to, let's say, 3.3.3.3.3.3. Of course, destination is going to remain the same. Destination is going to be 2.2.2.2. So I'm adding the source from 10.10.10.10 to 3.3.3.3 as I'm routing the packet out on the internet. And now this netted address, this is going to be the inside global. Inside global. And this makes sense because what this means is that this address is a mapped address of a host from the inside, because that's what it is. 333 is the mapped address of 10.10.10.10, which that was the address from the inside network. But it's called inside global because that's how the outside host is going to see the traffic flow source from 3333. So it's called inside global because when the router sends this traffic out on the outside NAT interface, out on the global network, which means the internet, there we go, the term inside global. So for me it's very simple, right? As long as you configure the NAT interface facing the LAN to be the inside NAT interface, and the interface facing the internet to be the outside NAT interface, it makes sense that as traffic flows from the inside to the outside, so from the LAN local area network to the global area network, which is the internet, and you're netting the source IP address, it makes sense that the real source is called inside local because it's an address visible on the inside NAT interface of the router. And because it's the real address, it means it's the address from the local area network. Then when the router routes that packet out on the internet, out on the global network, because it changes that IP address, it becomes inside global. So it's still an inside address because it's meant to represent that this is the mapped address of a host from the inside network. And it's called inside global because this is how that host from the inside is going to be visible outside on the internet, which means on the global network. So the terms make a lot of sense. Now, assuming that this is your network, let's speak about outside global and outside local. Assuming likewise that this is your network, and let's assume now that this inside host from here, it's a public service, like it is a FTP service or web service, which you want people from the internet to be able to access that resource. So now we're going to look at the reverse direction of the traffic flow. So I would want people from the internet to be able to reach that inside host, but the problem is that that inside host has a private IP address which is not routable. So I have to configure this NAT device to translate that address to be visible on the internet as a routable address, not as a private RFC 1918 address. So let's suppose that what I'm going to be doing is, again, let's suppose that this host, and let's put in here the green is going to be my global, which means the internet. So likewise, let's assume that this host on the inside has an address of 10.10.10.10, which is again private address. And I want, again, people from the internet to be able to reach that service, but because it's private, it's not going to happen. I have to make sure that this IP address is visible on the internet as a routable IP address, which means I'm going to configure this NAT device in here to actually translate that address of 10.10.10 to be visible on the outside network. So I want that 10.10.10 from the inside to be visible on the outside network as, let's say, 3333, because that's a public address. And again, also let's assume that this host in here that host from the internet has an IP address of 2.2.2.2. So now let's look in this traffic direction in here. When that outside host wants to reach that inside host to reach the web service or the FTP service or whatever. And again, I'm assuming, and that's a good design we should follow up, that this is going to be your inside NAT interface, and the interface facing the internet is going to be your outside NAT interface configuration wise. Outside NAT interface. So now, when the outside host initiates traffic towards the inside host, the source of the traffic is going to be 2.2.2, the outside host. Destination is going to be the mapped address of the inside host, which has to be routable on the internet. So now the router is going to receive that traffic. And based on its configuration, it has to now do destination NAT, or how they call it, untranslate. So in general, translation means you're gonna translate the source address from the IP header, that's source NAT. Destination NAT means you NAT the destination address from the IP header, which is also called unnatting in a lot of documents or a lot of specialty books. So when the router receives that traffic, is going to change. When the router receives that traffic and it has to route it on the inside network, it has to NAT the destination. So what this router is going to do, it is going to keep the source as it is, 2.2.2.2, but it's going to NAT the destination now to 10.10.10. So as the router routes the packet on the inside NAT interface, it's going to change the destination from 333 to 10.10.10. So it's doing destination NAT at this point. Now from the NAT terms point of view, in this traffic flow, this destination is going to be known, this destination in here, the map destination, is going to be known as outside actually it is, let me think if I chose the right example, because it's an address on the inside. So it's gonna be, let me give a couple of sentences. I'm not sure if I got the right example to confirm this. To make it easier to understand, actually we're going to do the following, because I'm gonna change the example as follows, because in general it's going to be easier to, I'm going to change the example for the following reason. Because on the iOS code where they define those terms, configuration wise, you're going to end up always doing source NAT. So that's a rule of thumb. Configuration wise, you're going to always do source NAT. It's just a matter of how traffic flows back and forth to the NAT device, if the router is going to actually do destination NAT or source NAT or both. But configuration wise, you're going to always end up configuring source NAT. So for that reason, let me do the following. Let's take this example. So let's take the same traffic flow. Let's consider again this to be the inside network in here as it is, and this to be the outside network in here as it is, which means this is going to be the interface facing the inside network, is going to be the IP NAT inside interface. So this interface is going to be my IP NAT inside interface. And this interface facing the internet is going to be my IP NAT outside interface. And we're going to look at the same traffic flow this way, from the LAN to the internet. And now let's assume that, for example, in this case, let's suppose that the inside host, because that can happen, a lot of companies still have a huge pool of public IP addresses, which they actually used for internal IP addressing. Let's suppose that this time the inside host has a public IP address, which is going to be, let's say, 3.3.3.3. And we're going to assume that now the outside host has a private IP address, which is going to be, let's say, 20, not 20, let's say 10.11.11.11. So that's a host which runs a FTP or a web service or whatever, which I want to be reachable out on the internet. So because it has a private IP address, it means that some device in here in the transport network has to translate that private IP address into a public IP address. And in my case, I'm going to consider that this router is going to do a translation to make sure that this private IP address is being visible on the other side of the router as a public IP address. So what is going to happen is that this host, which has that private IP address, I want the NAT device to translate that address to be public. And it's going to translate it to, let's say, 2.2.2.2. So that address of 10.11.11 from the outside NAT interface is going to be visible on the inside NAT interface as 2.2.2.2. And now let's look at the traffic flow going in that direction. So as the inside host initiates the traffic for that public destination, the packet is going to have a source of 333, the inside host, and a destination of 222, the mapped address of that public service, which actually has a private address. That's what this router is going to receive from the inside host. Now, based on this configuration, when the router has to route the packet on the outside NAT interface, it's going to translate the destination now back to its real IP address. So what this means is that when the router forwards the packet out on the outside NAT interface, it's going to keep the source as it is, 3.3.3.3, and NAT the destination back to what it actually is, 10.11.11.11. And now using this traffic flow and those interfaces as IP NAT inside and IP NAT outside, this destination in here is the host on the inside was accessing. This destination is going to be known as outside local, while this destination is traffic is routed on the outside NAT interface is going to be known as outside global. And again, this makes a lot of sense. Let's look at the first session. So what the inside host, session number 1, what the inside host initiates as a traffic flow, which is this source destination, which is called outside local. So that destination is called outside local. It's called outside because that address which I'm trying to reach is reachable on the outside NAT interface of the router, so out on the internet. And it's called local because that's how that address is visible locally on the local area network. Now, when the router, step number 2, routes the packet out on the internet. And it's going to know destination, that is going to translate the destination. This address is now called outside global because this address, this destination, is reachable, routable on the outside NAT interface of the router. And it's called global because that's how that address is visible on the global, which means on the internet, which means on the outside NAT interface. So it makes a lot of sense basically. So when you send a flow out on the internet from the LAN to the internet, and the router is going to destination NAT. So I'm going to initiate traffic out on the internet with a destination of, let's say, 999. From the router's point of view, that's going to be the outside local because I'm on the LAN, and that destination of 999 is routable out on the outside, the global, the internet. But it's called outside local because that 999 is what I see on the local area network. That's the IP address that I see on the local area network. But then when the router has to route the packet out on the internet and to destination NAT or untranslated destination, then that new destination is called outside global because that address is an address reachable on the outside NAT interface. And it's called global because that's how that address is visible globally out on the internet. So it makes a lot of sense if you just think about, again, about the history of NAT, which was always scoped to do initially source NAT only, and about the fact that CISCO invented those terms with the mindset of the inside NAT interface to be facing the local area network, and the outside NAT interface facing the internet or the global area network. So there you go. That's why we have the local and global terms back and forth in there.